So, have you ever looked at a huge, messy pile of data and wondered how on earth anyone turns that into a smart prediction about the future? Well, today we're going to pull back that curtain. We're going to see exactly how raw information gets cleaned up and transformed into an incredible predictive tool, all thanks to one of Python's most powerful libraries, Pandas. Let's dive in. This is the big question, right? How do you go from total chaos to crystal clear insight? And you know what? The answer isn't magic. It's actually a pretty methodical journey of cleaning, structuring, and then modeling that data. And we're going to walk through that journey step by step.
All right, here's our game plan. First, we'll talk about the problem, the modern data challenge. Then, we'll look at Python's toolkit for solving it. We'll get to know the heart of it all, the data frame. Then, we'll see how to handle real-world imperfect data. And finally, we'll put it all together to actually predict something.
Okay, first up, the modern data challenge. Now, that's just a kind of fancy way of saying something that anybody who's worked with data knows all too well. Real-world data is almost never clean and ready to go right out of the box.
I mean, just think about it. Data coming in from surveys or websites or sensors, it's going to have typos, it's going to have missing entries, weird formatting. It's a mess. So, before we can even dream of finding cool insights or making predictions, we have to roll up our sleeves and bring some order to that chaos. Honestly, it's the first and maybe the most important step.
So how do we actually fight back against all this mess? Well, this is where Python's incredible data toolkit comes in. These are the powerful libraries that let us wrangle all that chaotic data and get it into perfect shape.
And when we say library, what do we even mean? Well, think of it as a massive short count. It's a collection of code that really smart people have already written and perfected, so we don't have to reinvent the wheel every time we want to do something common, like, say, read a file or calculate an average.
Now, two of the absolute biggest names in this world are NumPy and Pandas. NumPy is like the bedrock for anything involving numbers. It's super fast, efficient, and perfect for math. But for what we're doing today, the real star of the show is Pandas. It is built specifically to handle data in tables, with rows and columns, kind of like a spreadsheet.
And that brings us right to the heart of the Pandas library. It's time to meet the data frame. The best way to think about it, it's like a super-powered spreadsheet that you can control completely with code.
So the official definition is that a data frame is a two-dimensional data structure. Big surprise, right? It's got rows and it's got columns, just like a table you'd see in Excel. But the key difference, the thing that makes it so powerful, is that it lives inside your Python code, which gives you the ability to change it, shape it, and analyze it instantly.
And this is where you really see that power in action. So let's say we have this table of student marks. If we want to add a new student, Fatima, we don't have to click around and type things in. Nope, it's just one single line of code. And boom, our entire data set is updated.
And you know what? The exact same idea applies to rows. If we suddenly need to add a new subject, like English, for all our students, again, one simple command is all it takes. This incredible flexibility, the ability to reshape your data on the fly, is exactly what makes data frames so essential.
Adding data is great, but getting rid of what you don't need is just as important. So here, we've decided to filter our data set. We've dropped the Hindi row and 3 of the student columns. In just seconds, we have a much smaller, more focused table. This is a huge part of the whole data cleaning process.
Okay, so we can add and remove data pretty easily. But what about those super annoying gaps, those empty cells? This brings us to the really practical challenge of handling data when it just isn't perfect.
Luckily, when you're dealing with missing values, there's a simple 3-step playbook. First, you use a function like isN'all to basically ask the data frame, hey, where are the holes? Second, you decide on your strategy. Are you going to drop the incomplete data, or are you going to try to fill in the gap? And third, you just apply the function that does what you chose.
Now, your two main strategies here each come with a trade-off. Using drop_NA is the quickest way. It just deletes any row that has a missing value. Simple. The downside? Well, you're losing data. The alternative is fill_NA, which lets you replace that empty spot with something else, maybe a 0 or even the average of that whole column. You get to keep your data, but you are making an educated guess.
All right, we did it. We've cleaned our data, we've structured it. Now for the moment we've all been waiting for. It's time to put that beautiful clean data to work and actually try to predict the future.
So for this, we're going to tackle a classic problem, predicting house prices. We've got a data set with all these features, like the average income in the area, the age of the house, how many rooms it has, and we're going to use a model called linear regression to figure out the relationship between all those things and the final price.
So, the very first step in building our model is to get rid of any information that just isn't going to help. For example, a specific street address is way too unique. It's not going to help a model predict prices for houses it's never seen before. So we drop that column, and that lets us focus on the real numerical features that matter.
This next step is absolutely critical in machine learning. We have to split our data into two parts. We'll call them X and Y. X contains all of our input features, so that's all the things we know, like the income and the number of rooms. And Y is our target. That's the one thing we're trying to predict. In this case, the price.
Now listen up, because here's one of the golden rules of machine learning. You absolutely cannot test your model on the same data you use to train it. Think about it. That's like giving a student the answer key right before an exam. Sure, they'll get a perfect score, but have they actually learned anything? Nope. And the solution to this problem is something called a train-test split. It's simple. We divide our data set, and we use the bigger chunk, usually about 80%, to train the model. Then we hold back that other 20%, we keep it separate, and we use it to test how well our model performs on data it has never, ever seen before.
This quote really says it all. The goal is to estimate the performance of the machine learning model on new data not used to train the model. See, this whole process is what ensures we're building a model that's actually useful in the real world, not just one that memorized the answers from its study guide.
And there you have it. We've gone all the way from a messy spreadsheet to a working predictive model. We've seen the tools that make it possible to find order in chaos and then use that order to get a glimpse of the future. So that really just leaves one question for you. Now that you've seen the toolkit, what problem would you solve first?